Alright, we're supposed to be using the properties of definite integrals to rewrite our sum or difference of these definite integrals as a single definite integral. First thing you want to make sure that you do is go ahead and investigate each of the definite integrals as they're given. Make sure that your intervals are all heading in the right direction. Make sure that the number on the bottom is smaller than the number on the top. If you don't see that to be the case in any location, make sure that you're switching your numbers so that it is going from least to greatest. And when you switch your numbers, make sure you account for changing the sign in front of the definite integral. Now in this particular problem, everything's good to go. So let's go ahead and start with this first interval, or integral rather, that is represented. This first integral, as it's represented, is talking about the interval from 5 to 6 and the area beneath the function curve there. So that area would correspond to this region. The next interval that apparently we are adding on, well, it's going to be the interval from -3 to 5, the area that is beneath the function curve there. So that's going to be all of this. So far, if we were to add those two definite integrals together, we would have a definite integral for this function that is based on the interval from -3 to 6. But now what we're going to do is we're going to take out, because we're subtracting, the interval for the area beneath this curve from -3 to 0. So -3 to 0 is going to be all of this section right here. We're taking that out. If that's what we're taking out, we see what's left. As far as what's left is the area beneath the curve from 0 to 6. So our definite integral would be based on the interval 0 to 6 as it's applied to this function curve.